Hi students and friends, welcome to the channel Learn and Teach by Ayaz. I will continue my video lesson for the topic moles. The learning outcomes for this video lesson state that the mole is a unit of amount of substance and that 1 mole contains 6.02 into 10 raised to power 23 particles. For example, atoms, ions, molecules. This number is the Avogadro constant. These are the relationships we have used in our last video lesson. Use the relationship amount of substance, mole, mass is provided, and you know the molar mass. You can get this molar mass, that is MR or AR, from the periodic table. To calculate A, the amount of substance, B, mass, C, molar mass, D, relative atomic mass or relative molecular formula mass, E, number of particles using the value of the Avogadro constant. In terms of particles, moles can be defined as the amount of substance which contains Avogadro's number of particles. 1 mole of any substance. For example, we have a metal. Sodium is a metal here. 1 mole of sodium metal contains 6.02 into 10 raised to the power 23 particles. 1 mole of oxygen gas contains 6.02 into 10 raised to the power 23 particles. 1 mole of water contains 6.02 into 10 raised to the power 23 particles. For sodium, we can also write atoms because metals contains discrete atoms. Oxygen, we know that oxygen gas exists in the molecular state. This is the formula of oxygen. So we can write molecules. In the same way, we can also write molecules for water. We know the formula of water, H2O. You have to learn this value. Otherwise, you can get this value from the periodic table if it's provided to you. Calculate the moles from the number of particles provided. Now I want to calculate the moles from the number of particles provided. The formula will be like this. Moles is equal to number of particles divided by Avogadro number. For instance, I want to calculate the moles for sodium, and the number of particles provided is 1.2 into 10 raised to the power 23 moles sodium. So we'll divide this value by 6.02 into 10 raised to the power 23. So we will get 0.199 or 0.2 moles. Now what if I want to calculate the number of particles from the moles of the substance? Now moles is provided. You want to calculate the particles. For instance, we have 0.5 moles of oxygen gas. We have the formula, that is number of moles is equal to a number of particles and divide it by Avogadro number. So number of moles is 0.5 and we want to calculate the number of particles. We'll write x here divided by 6.02 into 10 to the power 23, or x becomes x equal to 0.5 multiplied by 6.02 into 10 to the power 23. We'll get 3.01 into 10 to the power 23. Oxygen, we know that oxygen gas exists in the molecular state, so you write molecules for the particles of oxygen. Now, what if we are provided with the mass of the substance? For example, 32 grams of methane. Methane is CH4. Now, first of all, convert this into moles of CH. What is the MR of CH4? In order to get the moles of CH4, we have to divide this mass by the relative molecular mass of CH4, MR of CH4. We have one atom of carbon, so I will multiply 1 by AR of carbon. Here is a carbon. AR of carbon is 12. Plus, we have 4 atoms of hydrogen. AR of hydrogen is 1. So, if you'll add these, you'll get 16. So, divide 32 by 16. Number of moles of CH4, you'll get 32 divided by 16. You'll get 2 moles of CH4. Now we can easily calculate the number of particles. You have the equation. Number of moles is equal to particles by Avogadro number. I want to calculate the particles. So I will write number of particles is equal to number of moles multiplied by Avogadro number. Putting the values, we'll have number of moles is 2 here and Avogadro number is 6.02 into 10 to the power 23. So the answer will be 12.04 into 10 to the power 23, or correctly 1.204 into 10 to the power 24 molecules of CH4. Calculate the particles in 2 moles of lithium. You know the formula is you simply multiply the moles. X is equal to number of moles into Avogadro number. So we'll multiply 2 by 6.02 into 10 to the power 23. The answer will be 1.204 into 10 to the power 23. we have atoms of lithium. Lithium is a metal. 1.5 moles of water. Again, number of moles will be multiplied by the Avogadro number. So we'll multiply 1.5 by the Avogadro number. That is 6.02 into 10 raised to the power 23. We get 9.03 into 10 raised to the power 23 molecules of water. You know the formula of water is H2O. It means it contains molecules of water. Here's another question. Calculate the particles in 46 grams of sodium. We have to convert this grams into moles. So what will I do? First of all, I am going to write the formula of calculating number of moles from the given number of particles. We have these two formulas. First formula is moles is equal to number of particles by the Avogadro number. Second formula is for calculating moles from mass, and that is moles is equal to mass divided by MR. Here we have sodium, so I can't write MR, I will write AR. AR of sodium. So putting the value of moles, that's the equation number 2. In equation number 1, we will get this mass divided by AR is equal to number of particles divided by Avogadro number. If you rearrange this equation, you will get what? You will get this number of particles is equal to mass multiplied by Avogadro number divided by AR. Now putting the values, we will get this mass. Mass is provided, that's 46 grams. And Avogadro number, we know that 6.02 into 10 raised to the power 23 and divided by the AR of sodium, which is, I will show you, AR of sodium. Here is sodium and this is the AR. 23 is the AR. So we'll write 23 here. 23. So 46 multiplied by 6.02 divided by 23, 12.04. 12.04 into 10 raised to the power 23, or correctly, final answer will be 1.204 into 10 raised to the power 24. We have sodium, so I will write atoms of sodium. This will be the final answer. Calculate the particles in 50 grams of calcium carbonate. We have mass of calcium carbonate. The formula of calcium carbonate is CaCO3. Use the same technique, and that will be, I'm going to use this formula again. But in this case, in the second one, in this case, we have MR instead of AR. So 50 will be multiplied by 6.02 into 10 raised to the power 23 and divided by MR of calcium carbonate. So MR of calcium carbonate, CaCO3. We have one calcium atom. So I will multiply 1 by AR of calcium. Here it is calcium and AR of calcium is 40. We have carbon. AR of carbon is 12. we have oxygen, we have oxygen, AR of oxygen is 16. One atom of calcium means 1 multiplied by 40 plus 1 atom of carbon, 1 multiplied by 12. 3 atoms of oxygen means 3 multiplied by 16. So we will add 40 plus 12 plus 48. So this will become 100. So MR of calcium carbonate is 100. 50 divided by 100 will get 1 by 2. So 6.02 into 10 is power 23 divided by 2. What you will get? If you will divide 6.02 divided by 2, 3.01. 3.01 into 10 raised to power 23 molecules. Calcium carbonate is CaCO3 molecules. So this will be the final answer for this question. Thanks for watching. Press like, give comments and share my video. For more videos, subscribe my channel and press the